in this question, the two forces are not in the same direction but perpendicular to each other, and the charge Q here is positive, so there's an attraction downward toward this negative charge at the bottom. Okay, and this 2Q is also positive, so there is a repulsion by 2Q on the other charge Q in this direction on the line joining the two forces. Okay, let's call this is F1, the other F2. Yeah, and similarly you need to calculate F1 and F2, and they are the magnitude and also the angle between them, so that to find the net force you will use the cosine rule. You know that cosine rule in a triangle?
Yeah.
This is A, B, C, and we have C square equal A square plus B square subtract D. AB cosine the angle between it, cosine C. Okay, C A B, and so you need to find the angle between the two forces, so that you can apply the cosine rule to find the net force.
I thought it was just fine.
Yeah, this is, let me change the color. This is the net force. Okay.
Yep.
So to find that net force, we can consider this triangle. So we know the two sides, this side and this side. We need to find the angle between those sides, which is this angle. To find this angle, you can find this angle. Try it yourself. If you cannot find the angle, I will help.
Sorry, can you tell me which angle I have to find?
Let me draw the diagram below. Okay, you have F1 here and F2. So we can consider this bottom triangle, and we know the two sides, this side and this side. This side is F2. Okay, this is F2, this side F1, and to find the total F here, we need to know this angle, and it is difficult to find it directly. We can find this angle first instead, because in this parallelogram the sum of these two angles, alpha and beta, will be 180 degrees. Okay, so you can find the alpha angle here, therefore you can deduce for the value of beta.
Okay.
Yeah. There's a second way to find the net force. Using the force resolution, you find the total force in the horizontal direction, and then the total force in the vertical direction, and then add them together.
Yep. I think it's 53.
53 bit. Now calculate F1 and F2.
So in cosine rule, the F net equals to the C. I think it is 86.
86. Calculate side C. So side A is 90. Sorry, my fault. 141. And the angle, wait, angle 53. And side B is 101. Calculate. It is 86. Yes, very good. Okay, that's it. sometimes they can ask a little bit more, not just the value of the net force but also its direction. Okay, which direction of the net force. So to answer that question, you need to calculate this angle. Okay, let's say
Yep.
gamma. You do it similarly using the cosine rule above here. So consider this gamma as the cosine c here. Okay, so that cosine gamma will be equal to a square plus b square, meaning f net. Oh, let's plug the number into it. Okay, so let me write down here. Cosine of that gamma will be, I think you do that. So please keep doing that. Calculate cosine c from this equation. 86 square plus 90 square. You see, a and b in this equation is the two sides of the angle, and then subtract the opposite side of the angle, which is f2, which is 101 square, and then divided by 2 times of 86 and 90. Calculate the angle C, where A is 101, where 86, the other is 90, and the opposite side is 101. What is your result?
Sorry, just a minute. 70.
Yeah, 70 degree. Yeah, the calculator online.
Yep.
Yeah, so gamma is 70 degrees. So we can conclude that the net force makes an angle of 70 degree to the vertical direction and to the left. Okay.
Okay. Thank you.
Bye bye.
See you next week.
Yeah.